Okay, welcome to section 1.3. Today we're going to look at solving linear equations. We're going to solve equations that have a variable just on one side of the equal sign, then there's going to be a variable on both sides of the equal sign, and lastly we are going to work with solving equations that use the distributive property. So let's get started. Alright, so the first thing we're going to do is just solve our linear equations. And as I said, we're going to start with a variable on one side. Okay. So let's look at a problem here. We've got 6x minus 8 equals 10. A little basic equation here. It's going to take 2 steps to solve. When we're solving an equation, just as a little reminder, is we want to get the x alone, or the variable, whatever the variable is. We want to get that variable alone. And we're always going to be using opposite operations. So here I see a negative 8 or a minus 8. So the opposite of subtraction is addition. So the first step is going to be to add 8 to each side. So negative 8 plus 8 is going to give us 0. That's what we want. We're starting to cancel away all the numbers that are on the same side as that variable. So I'm left with 6x equals 10 plus 8 gives me 18. So I've got 6x equals 18. I can see the 6 is attached to the x through multiplication. To get rid of it, we have to do the opposite operation. The opposite of multiplication is division. So I'm going to divide both sides by 6. Alright, so 6 divided by 6 is 1. 1 times x just gives you x. 18 divided by 6 is 3. So we can see x equals 3. Just to make sure we're correct, we are now going to check. And we're always going to check with our original equation. So our equation is 6x minus 8 equals 10. Our first step is going to be to take 3. We know the value of x is 3, so instead of x in our equation, we're going to plug in 3. So we've substituted 3 for x. Alright, now we are going to simplify the left side of the equation, and hopefully it will equal 10. So we have to use our order of operation, PEMDAS. Please excuse my dear Aunt Sally. However you want to remember it, we need to realize, though, that the multiplication has to be done first. So 6 times 3 is 18. And then last, we see 18 minus 8 is, in fact, 10. Good. So we've simplified. And it's correct. We need to make sure that these numbers equal each other. So we did a good job. So let's take a look at one more. We've got 7 plus 5/3 x equals negative 13. So again, we can see x is attached to the fraction 5/3 through multiplication, and we've got a positive 7 over here. So in order to get rid of that positive 7, we want to subtract the 7. So if you see addition or subtraction is possible, you're always going to want to do that first when you're solving an equation before you multiply or divide. So 7 minus 7 gives us 0, and we're left with 5/3 x equals negative 13. Take away 7, we're left with negative 20. Alright. So, unlike the previous example where we just had a whole number attached to it, now we have a fraction. So we need to get rid of this fraction. What can we do to this side of the equation to make 5/3 equal 1? Well, you can either divide by 5/3, or when working with fractions, I like to multiply. So I'm going to multiply by the reciprocal. So the reciprocal of 5/3 is 3/5. So I'm going to multiply both sides by 3/5. And we can do some cross-canceling. The 3's cancel, and the 5's cancel. And we're left with 1 times x again, which is just x. And we can do some cross-canceling here as well. Right? Negative 20 is the same as negative 20 over 1. 1 and 3 can't be cross-canceled. But 5 does go into 20. 5 goes into 20 4 times, so we're left with a negative 4. And 5 goes into 5 just once. So multiply the bottoms, you get 1. Multiply the top, negative 4 times 3 gives us negative 12. And that's our answer. So just like the previous problem, we are going to check. So I'm going to say 7 plus 5/3 times x equals negative 13. I have to plug in my value of x, which is negative 12. Equals negative 13. So now we're in a similar situation as we were up here. We want to see if we can do any cross-canceling. So I'm going to put negative 12 over 1, because whenever you have an integer or a whole number, it can always be put over 1, because anything divided by 1 is itself. So negative 12 divided by 1 is still negative 12. So we can do that. 5 and 1 can't be simplified. But does 3 go into negative 12, or does 3 go into 12? And it does. So 3 goes into 12 4 times. 3 goes into itself once. So I can simplify this piece right now. We see the denominators are just 1, so we don't really need those. I'll just cross them out. So 5 times negative 4 is going to give me negative 20. And then lastly, I just want to simplify the left side here. 7 plus negative 20, that gives me negative 13. And it checks out. So we know our answer is x equals negative 12. If you ever get a scenario where the left side of the equation doesn't equal the right side, you know you've done something wrong. So you need to go back and check your math in your check. Make sure you didn't make a simple algebraic error. And if you're confident that that's correct, everything here, then you need to go back up into your equation and make sure you did everything right here, because obviously something is wrong, because it should always have 2 of the same numbers on either the equal sign. Okay, so that is working with variables just on one side. Now we're going to look at variables on both sides. Alright, so the first problem, we are going to see 8z plus 7, and that's going to equal negative 2z minus 3. So we can see our variable is no longer x, it's z. That's fine. Any variable could be x, y, z, any letter of the alphabet. It's going to act the exact same way. When you have variables on both sides of the equation, the first thing you're going to want to do is combine like terms. So our like terms in this case are, we've got 8z, anything with a z is going to be like. So we got 8z and negative 2z. And what we have left then are just our constants, which are our numbers without any variable attached to them, 7 and negative 3. So these are our like terms here, so we're going to try and combine them. How can we do that? Well, there's more than one way. If I have a negative, I'm going to try and add it over. If it's a positive, I'm going to want to subtract it over. Alright, so it just depends on if you want to move the negative 2z or the 8z. Like I said, there's no wrong way. So for our purposes, I'm going to get rid of this negative 2z. So since it's a negative, I need to do the opposite and add it to both sides. So I'm going to add 2z to both sides. Negative 2z plus 2z is 0. 8z plus 2z will give me 10z. And then I got 10z plus 7 equals, and all we have left on the right side of the equation is negative 3. So I have moved the z from the right side of the equation to the left. Now I need to start getting the numbers away from the left side of the equation, because now we only have one variable, right? So I've got a 7 on this side and a 10 I need to remove. So I'm going to start, remember I said if you can add or subtract, do that first before you multiply or divide. So I see a positive 7 or a plus 7, so the opposite of addition is subtraction. So I'm going to subtract 7 from both sides. That's going to cancel, and I'm going to get 10z equals negative 3 minus 7 gives me negative 10. Now I see, oh, very similar. So 10 will go into negative 10 pretty easily. I'm going to divide both sides by 10 now, because we've got 10 times z. The opposite of multiplication is division. And I'm left with z equals negative 1. Great. So we again are going to check. So we're going to use our original problem, 8z plus 7 equals negative 2z minus 3. And wherever I have a z, in this case it's in two places, I'm going to plug in a negative 1. So we'll go 8 times negative 1 plus 7 equals negative 2 times negative 1 minus 3. And now when you're checking, you're not moving things on either side of the equation. You're just simplifying the left side and simplifying the right side and hoping that they are the same. So negative 8 times negative 1, or positive 8 times negative 1 gives me negative 8 plus 7. Negative 2 times negative 1 gives me positive 2 minus 3. And then I see negative 8 plus 7 is going to give me negative 1. On the right side, 2 minus 3 is going to give me negative 1. And I can see negative 1 definitely equals negative 1, so I know I've done it correctly. And this is just chance that these numbers match. Most of the time they will not. Alright, let's look at one more, and then we're going to move on to the distributive property. So our second problem in this section is 7.3 minus 4.23x equals 7.27 minus 4.2. So we've worked with fractions, now we're going to work with decimals. It's the same process, just a little bit more complex math. So I want to identify those like terms. Oops, I'm missing my x here. And so I can see I have negative 4.23 and 7.27. Both of those have x's. Right, so I'm going to want to combine those terms, and I'm going to combine my constants, which are 7.3 and negative 4.2. So I'm going to start by bringing this. In the previous problem, we brought the variable from the, I'll scroll back up there so you can see, we brought the variable from the right side to the left. Now, I'm going to bring it from the left side to the right to show you that you can do it either way. So I'm going to add 4.23x to both sides. Notice I'm lining up my decimals so it makes math easy. So I'm going to add all these, and I am going to get 11.5x minus 4.2. What's left on the left side of the equation? It's just 7.3. So since I brought the variable from the left to the right, I now have to bring a constant from the right to the left. So I'm going to add 4.2 to both sides. and I am going to get 11.5 equals 11.5x, and that works out really nicely, because when I divide both sides by 11.5, and I'm dividing because there's multiplication connecting the coefficient to the variable, so I want to make sure I'm doing opposite operations. As I said before, 11.5 divided by 11.5 is 1. 1 times x is x, so those can cancel, and I get 1. So things are looking pretty nice. When I get a 1 or a negative 1, it makes checking pretty easy. But you always still want to check to make sure you're getting the correct answer. So my original problem is 7.3 minus 4.23x equals 7.27x minus 4.2. So I'm going to plug in my value of x, which is 1, to both spots in this equation. And we know anything times 1 is itself, so I'm still left with 4.23 here, and I'm still left with 7.27 minus 4.2. And now all I have is basic subtraction in both cases. 7.3 minus 4.23 is going to give me 3.07, and 7.27 minus 4.2 gives me 3.07. So it works out. Alright, so on to the next piece is using the distributive property. Alright, so this will be a little bit of a review as well. So we've got 2 times the quantity, 3x plus 1, is equal to negative 3 times the quantity x minus 2. First thing, we can see all there is to do on the left side of the equation, all there is to do on the right side of the equation is to distribute. If you have a quantity, meaning a variable minus a number in a parentheses in this case, multiplied by something on the outside, you have to do the multiplication first if there's nothing to do simplify in the parentheses, because remember, we're still working with PEMDAS. Please excuse my dear Aunt Sally. So you want to look at the parentheses first, but there's nothing to simplify. We can't combine an x with a constant, or a variable with a constant. You can only combine variables with variables, constants with constants. And so we have, yes, this looks like a constant, but it's connected through multiplication. So this is one term here, so we can't connect 3x with the 1 either. So there's nothing to simplify in the parentheses. We have no exponents, so all there is to do is the multiplication, which is our distributive property. And if you remember, when you distribute, you have to distribute to all terms in the parentheses. In this case, there's 2 on both sides of the equation. So the first thing here is distribute. So I'm going to actually erase this PEMDAS so I can write down our process. So we will distribute here. And so we're multiplying 2 times the first term. So 2 times 3x gives me 6x. 2 times the second term, 2 times 1, gives me 2. Negative 3 times x, or 1x, gives me negative 3x. Negative 3 times negative 2 gives me positive 6. Negative times a negative is a positive. And now this just looks like the equations we just solved with variables on both sides of the equation. So you would just follow the same process as we did in section B, or part B of this video. So now I'm going to add 3x to both sides because I want to combine my like terms. So I've got negative 3x plus 3x, that cancels, and I get 9x plus 2 equals 6. So I've combined my terms with the variable. Now I want to combine my constant, so I'm going to bring my negative 2, or my 2 over, so I'm going to subtract 2 from both sides. And I'm subtracting because the opposite of addition is subtraction. 2 minus 2 is 0. So I'm left with 9x on this side. 6 minus 2 is 4. Now, I see 9x. 9 is connected to x through multiplication. So I'm going to divide, and my final answer is going to be, because 9 divided by 9 is 1. 1 times x is x. We see x is 4/9. Now don't freak out when you get a fraction. A lot of students will say, oh, I got a fraction, it must be wrong. Or I got a decimal, it must be wrong. No, it's definitely not the case. It's okay to get fractions. You need to check to make sure you got the problem right. So just as we did for every problem, we're going to check. So we got 2 times the quantity, 3x plus 1 equals negative 3 times the quantity, x minus 2. That was our starting problem. So just like before, I'm going to substitute the value of x in for each spot. So I've got 4 over 9. Actually, let me rewrite that so we can cross-cancel nicely and you can see that. So I'm going to say 4 over 9 plus 1 equals negative 3. 4 over 9 minus 2. And just like we did before, 3, anything over 1 is itself, so I'm going to do 3 divided by 1. And now, this is where the PEMDAS comes in again. You have to look, oh, I've got parentheses, so you can't multiply yet. You need to simplify in the parentheses first. When I say multiply yet, I mean multiply the 2. There is multiplication here, and that's what we're going to deal with first. So, and we can do that through cross-cancellation. 1, 4. 1 doesn't really go into 4, that doesn't help us. But 3 can go into 9. 3 can go into 9 3 times. And then 3 goes into itself once. So I've got 1 over 1, which is 1, times 4 divided by 3. So I'm left with 4/3 here, plus 1. And I'm going to whenever I have a fraction, I'm going to try and rewrite, if I have a constant with it, as a fraction. So 1 can be rewritten as 3 over 3. And the reason I do that is it's going to help me add this fraction easily. And you remember the rule of adding fractions is all the denominators have to be the same. Right? So I had to change 1 over 1 to 3 over 3 because my denominator here is 3. So now I've got on this side negative 3, and there's really not much I'm going to do here yet because I'm going to do the adding and the subtracting together. But what I am going to do is I'm going to rewrite this number so it has 9 as a denominator. So negative 2, or negative 2 over 1, I'm going to rewrite so it has a denominator of 9. 1 times 9 is 9. 2 times 9 is going to give me 18. You always want to check, does 18 divided by 9 equal 2, or negative 2 in this case, and it does. So now I'm going to add and subtract. So I've got 2 times 4 plus 3. That's going to give me 7/3. And that's going to be equal to 4 minus 8. That's going to give me negative 14/9. So now can I cross cancel? 1 can't go into 7. Can 2 simplify with 3? No. So I'm just going to multiply across. 2 times 7 is 14. 1 times 3 is 3. Can I cross cancel here? And I can. Notice they're both negative, so 2 negatives are going to make a positive. 3 goes into 9 3 times. 3 goes into 3 1 time. And 1 times 14 is 14. 1 times 3 is 3. So it will simplify, and I'll see I'll get 14/3 on both sides. So I know my answer, which was a fraction of 4/9, is actually correct. Okay. Let's do one more in this section here. So we are going to do number 2. And let's do this problem. 5 times the quantity x plus 3 equals negative, or negative 1, times the quantity x minus 3, or the opposite of the quantity x minus 3. All right. So, same thing as above. We want to start with distribution in this case. All right. Whenever you have a negative on the outside, it's just like having a negative 1. So I'm going to distribute the negative just as I would a negative 1 or a negative 2 or whatever number it is. And I'm here still going to distribute my 5. So 5 times x is going to give me 5x. 5 times 3 is 15. Negative times x, or the opposite of x, is negative x. The opposite of negative 3 is positive 3. So now I've got just two variables on both sides of the equation, so I'm going to just combine like terms. So I'll start by combining my variables. So I'm going to add the x over to both sides. That's going to cancel, and I'm going to be left with 6x plus 15 equals 3. Now I'm going to combine my constants. So I'm going to subtract 15 from both sides. And I'm going to get 6x equals negative 12. Divide both sides by 6. And I get x equals negative 2. Much nicer to work with here on our check than the fraction. Alright, so this will be a quick little check. So I've got 5 times the quantity x plus 3 is equal to the opposite of the quantity x minus 3. So I'm going to substitute in negative 2 for x. And now I'm going to start simplifying. So in parentheses first, negative 2 plus 3 is 1. And negative 2 minus 3 is negative 5. 5 times 1 is 5. The opposite of negative 5 is 5. And we can see 5 equals 5. So we know we've done the problem correctly. All right. So that's section 1.3. That's all. Thank you.